everyone, and welcome to lesson 35.2. Today's notes are attached in Google Classroom, or you can just take notes on a separate sheet of paper. Today's first big formula is that of a volume of a pyramid. It's very similar to the volume of a prism, but you only want a third of it. So the process is very similar to what we did with our prisms. Each time we are going to need to identify our base shape, we will need to calculate the area of that base. So in our first picture, we have a square as our base, and the area of the base is found by taking base times height, or side squared, 6 times 6, which is 36. Next, we need to identify the height. The height is from the vertex to the base. So in this case, our height is given to us as 5 centimeters, and we can calculate the volume, take 1/3 of that area of the base times our height. Now, when you type this in your calculator, you have two options. You can either do 1/3 times the area of the base times the height, or you could do area of the base times the height and divide that answer by 3. It's the same process. Either way, we got 60 cubic centimeters. Remember, volume is units cubed. Our next example has, again, another square base. Okay, so the area of the base this time, again, is base times height, or side times side squared. 9 times 9 is 81. The problem with this next example, though, is that we are not given the height, we are given the slant height. So what we need to do is calculate, using Pythagorean theorem, the height given the slant height, and that if our side length is 9, half of that would be 4.5. So our slant height, 12.1 squared, is going to equal our height squared plus our base squared of 4.5. 12.1 squared minus 4.5 squared can be done right in your calculator. So 12.1 squared minus 4.5 squared gives us a total of 126.16. And we know we need to just square root that value in order to get the height. So when we square root this answer, we get a total of 11.2. Now we have our height, and we can ultimately find the volume by taking 1/3 that area of the base times the height we just found, for a total of 302.4 cubic feet. Next, we want to be able to also work backwards. The next one telling us we have a square base, right? We have a square base, and the overall volume is 32, and we're given a height of 6. So think about plugging in, working backwards here. We have area of the base times height divided by 3. They gave us the volume. They told us it was 32. We don't know the area of the base, but we do know the height is 6. So first things first, let's solve for the area of the base. Multiply both sides by 3. We get 96 equals 6 times the area of the base. And when we divide by 6, 96 divided by 6 is 16. Now, our overall goal is to find the side length of this base. Right now we have the overall area is 16. And if this is a square, we know the side lengths are the same, aka side times side, or side squared, is 16, square root, and we just get our side length of 4. We also can work backwards to find the height. Again, if they give us area of the base times the height divided by 3, this time they're telling us the volume is 6,000, the area of the base is 300, the height is what we're looking for, and we know that value divided by 3 is our overall volume. So start again by getting rid of the division by 3 by using some multiplication. We now have 18,000 equals 300h. Divide by 300, our height is equal to 60. Now, the next piece of today is talking about the volume of a cone. Similar to how a pyramid is 1/3 the volume of a cylinder. Our cone is 1/3 the volume of a cylinder. So we can take 1/3 of the volume of the cylinder and we can find our area of a cone. So again, we need two things. We need the radius and we need the height of our cone in order to calculate this. On our first example, the radius is 3, the height is 2. So as we plug in 1/3 times pi times our radius squared times the height, we can get our volume. And again, doesn't matter if you type it in as 1/3 times pi times r squared times h, or if you type it in as pi r squared times h divided by 3, so you see it this way as well, we get the same answer of 18.8. Again, inches cubed on this one. Our units are always cubed with volume. Now, again, always be careful that you are going to use your radius because this next example gave us the diameter. We know we need the radius, half of that, and the height of the cone in order to find our volume. So pi times the radius squared times the height divided by 3. You should get about approximately 47.1 as your answer. Now the last two, again, want us to plug into this formula of pi times the radius squared, times the height in order to work backwards, and in this case, find the height. So this time they gave us the volume is 66. And they also gave us that the radius is 3. So pi times 3 squared times h, all divided by that 1/3, or multiplied by 1/3 divided by 3. So I'm going to start by multiplying both sides by 3. I get 198 on this side, and then I have 9 when I take 3 squared times pi times h. Well, again, be careful. Calculate 9 pi in your calculator first. Get that approximation before you solve for h. So 9 pi is about 28.3. And we're going to divide 198 by 28.3 to get our final answer, which is right about 7, 6.996. Round it up and say that h is equal to 7. Our second example here is going to ask us to find instead this time the radius. So again, we're going to plug in volume is pi r squared h divided by 3. This time the volume is given to us is 8143 times pi times our radius squared, which we don't know, times our height of 30. So to start, I'm going to multiply both sides by 3, cancel this out, and we get that 3 times 8,143 as 24,429. We end up with 30 times pi times r squared. Again, take a moment to approximate 30 pi in your calculator so you don't get the order of operations confused. 30 pi is 94.2. And when we divide the 24,429 by 94.2, we get r squared to be approximately 259.3. Now, that is not your answer. You don't want your radius squared. The question is just asking us for the radius. So in order to get r by itself, we have to square root our answer. So square root of 259.3 is just about 16.1. All right. Thanks everyone for watching. And we are now finished with the surface area and volume of our cones and cylinders, which we will work more with in class.